Here is a situation where we are going to analyze the center of mass of a two-unit or two-object system, and the two objects are going to start at rest and end at rest. So in this scenario, we know that because they said that this zookeeper and this polar bear are starting off stationary. And I guess we have a rope, okay, so I could have, this guy's gonna get this polar bear with a rope. But they are separated by 20 meters. Let's put the man at 0, and we can put the polar bear at 20. Okay, and the piece of information that they're stationary is important because what we learned is that when the initial velocity of the center of mass is 0 and there are no forces, outside forces interfering. Yes, we've got a force of the rope, force of tension between the two objects, but we're considering that an internal force. So if there are no outside forces, that's why we've got them on ice. So there's no friction, there's no slant here, so there's gravity is not a factor. So then when there are no outside forces acting on the system, we know that the velocity is not of the center of mass is not going to change. So then we know the final velocity of the center of mass will also be 0. And that means that the center of mass initial is going to be in the same spot as the center of mass final. So all I need to do here is solve for the initial center of mass, and I will know that the final center of mass is the same spot. And then what they're really asking for here is when the zookeeper pulls the polar bear to him, how far will the polar bear have moved? So basically, like, here's the center of mass. And how far has the bear gone from 20 to that spot? Which basically, so all I need to know is the center of mass, because then I'll just subtract from that to get my answer. So that's pretty easy because I know that the initial speed was 0, the final velocity of the center of mass is also going to be 0, and therefore the center of mass location has not changed. So let's just use our center of mass equation, and then they are giving me weights here, not masses, but because the newtons are going to cancel, I'm just going to plug them in. So here's the equation we're used to, which is the weight of the zookeeper times he's located at 0 on my coordinate system. Plus, here, let me shift these guys down here. Oops. Okay.
College students, please come to the box office. Laura Mikowski, Jaden O'Brien, Jordan Ball, and Oriana Ognar. Again to the box office. Laura Mikowski, Jaden O'Brien, Jordan Ball, and Oriana Ognar.
So when I do that on my calculator, I end up getting 16.7 meters. Notice here, like, I've got newtons canceling, and then I've got meters. So now that we know that the center of mass is at 16.7, then the polar bear we know the polar bear will end up moving from 20 to that spot to get where he meets the zookeeper. So the polar bear is going to move 3.3 meters.